It all starts with one small action, a single step. It feels ordinary, almost boring. But inside your body, that step activates a complex biological sequence that scientists have spent decades trying to fully understand. The moment your foot touches the ground, your nervous system detects movement. Muscles contract, sensory nerves send signals upward to the brain. Your body instantly realizes that energy demand is about to increase. There is no delay. Your heart rate rises slightly. Blood vessels expand to allow more blood to pass through. Oxygen-rich blood begins flowing toward the muscles that are now working. Breathing deepens naturally, without any conscious effort. Oxygen delivery increases, and carbon dioxide removal speeds up. On the surface, you may feel calm. Internally, your metabolism has already shifted gears. Within seconds, your cells increase production of ATP, the molecule that powers every movement, every thought, and every internal process. Enzymes responsible for breaking down fuel activate energy pathways that were quiet just moments ago start working again. This is the first stage of what scientists call metabolic activation. During the first few minutes of walking, your body relies on the fastest fuel available. Glucose is already circulating in your blood and stored inside your muscles, making it the quickest way to meet immediate energy needs. At the same time, subtle hormonal changes begin. Adrenaline rises just enough to increase alertness and readiness, not stress. This helps your cardiovascular system respond efficiently while keeping your nervous system calm. Your lungs automatically adjust. Breaths become deeper and slightly faster. Oxygen uptake increases while carbon dioxide output rises. Calorie burning begins almost instantly, even though the movement feels easy. Even in this early phase, your cells are no longer operating in a resting state. They have entered an active metabolic rhythm. As walking continues, your body begins preparing for a deeper and more meaningful shift. Muscles release small signaling molecules into the bloodstream. These signals communicate with distant tissues, informing the body that movement is continuing and energy demand may rise further. Fat cells receive these messages. Fat cells are often misunderstood. They are not passive storage units. They are biologically active and constantly responding to hormonal and neurological signals. When walking continues beyond the initial minutes, fat cells begin adjusting their internal behavior. They prepare to release stored energy if the body requests it. At the same time, insulin levels begin to fall slightly. This happens because active muscles absorb glucose directly from the blood without requiring insulin. Lower insulin levels are critical. Insulin acts like a lock that keeps fat trapped inside fat cells. When insulin drops, that lock loosens. Inside fat cells, energy is stored as triglycerides. These molecules are tightly packed and stable, designed to hold energy safely for long periods. When the body signals a need for fuel, enzymes inside the fat cell activate. This marks the beginning of lipolysis. Triglycerides break apart into fatty acids and glycerol. These smaller molecules exit the fat cell and enter the bloodstream, where they are transported to tissues that need energy. This is the moment fat officially leaves storage. Working muscles absorb these fatty acids and deliver them into mitochondria, the structures inside cells responsible for energy production. Inside the mitochondria, fatty acids are broken down through a process called fat oxidation. This process is slower than burning glucose, but far more efficient and sustainable. This is where walking becomes unique. High-intensity exercise demands rapid energy and relies heavily on glucose. Walking keeps energy demand moderate, giving fat enough time to be released, transported, and burned efficiently. As walking continues, mitochondria increase their activity. Oxygen use stabilizes. ATP production becomes steady and reliable. With regular walking, the body adapts by producing more mitochondria. This adaptation improves endurance, metabolic health, and overall energy efficiency. Mitochondria do more than produce energy. They send signals that influence inflammation levels, hormone sensitivity, immune function, and even aging processes. This means walking is not just about burning fuel. It is about improving how your cells function at a fundamental level. Scientists have observed that around 30 minutes of continuous walking represents a key metabolic threshold. In the early minutes of walking, glucose still plays a major role, but as time passes, glucose availability slowly declines. Instead of treating this as a problem, the body treats it as an opportunity. Hormonal signals shift, insulin remains lower, glucagon increases slightly, adrenaline stays steady. Together, these signals encourage fat cells to continue releasing stored energy. Oxygen consumption reaches a stable level. This is important because fat oxidation requires oxygen. When oxygen delivery stabilizes, fat burning becomes smoother and more efficient. At this point, your body is no longer warming up. It is fully engaged in fat oxidation. Most people do not feel this transition, but internally, it marks one of the most important shifts for long-term fat loss. The more frequently your body experiences this shift, the better it becomes at it. Over weeks and months, your metabolism adapts. Fat becomes easier to access. Energy levels become more stable throughout the day. This is one reason people who walk consistently often report improved endurance, fewer cravings, and better mood control. Here is a surprising scientific fact. Fat does not disappear as sweat or heat. When fat is burned, its carbon atoms combine with oxygen and leave the body mainly through your breath as carbon dioxide. The remaining components turn into water and are eliminated naturally. This means most of the fat you lose leaves your body through your lungs. Fat cells shrink because their stored contents are gradually released and converted into energy, molecule by molecule. As fat cells shrink, inflammation in surrounding tissues decreases. Blood flow improves. Tissues become healthier and more elastic. These internal changes eventually show up on the outside. Walking also improves circulation to fat tissue. Better blood flow allows hormonal signals to reach fat cells more effectively, making fat release easier over time. Regular walking even changes fat cells at a genetic level. Research shows that consistent low-intensity movement reduces the activity of genes involved in fat storage and increases the activity of genes involved in fat breakdown and inflammation control. Fat cells become less resistant and more cooperative. This is why consistency matters more than intensity. Every walk removes a small amount of stored energy. At first, the change is subtle, but over weeks and months, these small changes accumulate into visible fat loss. Walking also produces powerful effects inside the brain. As you walk, neurotransmitters such as serotonin and dopamine rise gently. Mental clarity improves. Stress decreases. Mood becomes more stable. Blood flow increases to areas of the brain responsible for focus, planning, and decision. Walking also triggers the release of BDNF, a molecule that supports brain repair, learning, and long-term cognitive health. This supports memory, focus, and emotional resilience over time. Appetite hormones also begin recalibrating. Ghrelin, the hormone that triggers hunger, becomes more stable. Leptin sensitivity improves, helping the brain recognize fullness more accurately. This explains why people who walk consistently often experience fewer cravings and better appetite control. Walking also reduces chronic inflammation. Muscles release anti-inflammatory signaling proteins that calm overactive immune responses. These effects build gradually with repetition. Lower inflammation improves insulin sensitivity, hormone balance, and metabolic efficiency. Unlike intense workouts that spike stress hormones and increase hunger afterward, walking keeps the body in a calm, fat-focused state. It is sustainable. It requires no recovery period, no special equipment, and no extreme effort, because it is easy to repeat daily. Its benefits compound naturally. Walking places minimal stress on the joints, making it accessible for nearly all fitness levels and age groups. The rhythmic movement supports circulation, lymphatic flow, and muscular endurance without exhausting the body. Over time, your body becomes more efficient at mobilizing fat, managing energy, and maintaining internal balance. By the time a walk ends, metabolic processes continue working for hours. Fat cells continue releasing energy. Hormones remain balanced. Mitochondria stay active. What feels like a simple daily habit is actually a full-body recalibration. Walking reshapes how your body stores energy, burns fuel, regulates hormones, and supports long-term health. Every system responds to movement, and all of it begins with the most basic human action. One step. If this video helped you understand how walking transforms your body from the inside, make sure to like, subscribe, and share it with someone who could benefit from this knowledge. Because sometimes, the most powerful changes come from the simplest actions.